In this mini lecture, we're going to cover a Tukey honestly significant difference test. At the end of the last mini lecture, we made a conclusion that the mean number of psychotic episodes experienced differed significantly between at least 2 of the drugs tested. And this is the data that we saw at the end, and we rejected our null hypothesis. So here we're looking at a plot of the 3 different drugs and the number of psychotic episodes, with the mean and standard deviation bars are shown, and up above I've indicated the mean for each of the treatments. And through the ANOVA analysis, we rejected our null hypothesis, which means that there's less than a 5% probability that the difference we're seeing is just due to random chance. However, all an ANOVA will tell us when we reject the null hypothesis is that at least 2 of the means are different, and we do not know which ones that is. So what we can do is this Tukey's test to figure out which means differ. When we look at the calculation for the honestly significant difference test, we're going to take the mean for the 2 treatments that we want to compare. We're comparing 2 treatments at a time. And then we have a value for the standard error. This is based on our mean square error, which we have in our table. And our mean square error we have in our table has a value of 2.694, so we're going to use that in our calculation. So mean square error, it's the same regardless of which 2 you're comparing. So that's 2.694. And then this is the sample size of individuals in the treatments. In our case, the number of individuals in the treatments was always 4, and that was the same. There's a slightly different version that you would use for this calculation if your sample sizes are not equal, but for all of ours there were 4, so it's going to be, to calculate our standard error, it's 2.694 divided by 4 and take the square root of that. So we're going to be doing this for each set of pairs. So we're going to compare drug A and drug B. So we have drug A mean minus drug B mean, and then the standard error. So it's 7.25, which is our mean for drug A, minus 6.75, which is the mean for drug B, divided by the numbers that we have up here, which gives us a value of 0.61. We'll do it for B and C. So here there are 2 values. Remember, the mean for drug C is quite low. It's 2.25. The denominator is the same because all of our sample sizes are the same. We get a value of 5.48. And then finally we'll compare treatment with drug A and the treatment with drug C, and we get a value of 6.09. Then we wonder if these differences are statistically significant. And we look at table G, and when we look at table G, up at the top we're looking at the number of levels of the independent variable, and we have 3 different levels of our independent variable. We have 3 different drugs, and our degrees of freedom error we have in our table that we put together. So our degrees of freedom error is 9. So we have 3 levels of our independent variable. Our degrees of freedom error is 9. So our critical value is 3.95. And when we look at our data that we have here, we see that the difference between A and B is not significantly different because their value that we calculate would have to be larger than our critical value. Our value for B and C is larger than our critical value, so that one's statistically significant. When we compare A and C, it is also statistically significant. So A is different from B, B is different from C, but A and B are not different from one another. If we look at our data again, our conclusions from our Tukey's test say that A is different from C, that B is different from C, but that A and B are not significantly different from one another. Sometimes how this will be indicated is you'll see letters that will group together the treatments that are not significantly different from one another. So A and A, those ones are not significantly different from one another. And then we have another group over here that's B that's just drug C by itself because it is different from those two. So sometimes you'll see that notations in paper. And so that is how we would do a Tukey's honestly significant difference test.